Hello children, welcome back to my channel Online Physics Class by Niharika. So children, in the last class we have studied about the term velocity. What is velocity and its formula, SI unit of velocity. Okay, then we have studied about uniform velocity. Then the two important points which we have studied, that how can the velocity be changed is by changing the speed of the body and by keeping the speed constant by changing the direction. So all these points I have already explained you in the last class. If you have not seen that video, kindly go and watch that video and also like and subscribe my channel. Now children, in today's class, we are going to study some important points related to speed and velocity. Okay, so the point is here, speed and velocity are not equal, not always equal in magnitude. So what are the situations when speed and velocity are not always equal in magnitude? Now the very first point is the magnitude of speed and velocity of a moving body is equal only if the body moves in a straight line. Now what does it means that magnitude of speed and velocity of the moving body moving is equal if the body moves in a straight line? So what is the meaning of this sentence, children? It is said here that suppose the body is moving, let me show you how. Children, let me show you that suppose a body is moving along a straight line A to B. Okay. In this case, let us say that the speed of the body is 40 kilometer per hour from point A to B. So we can say that its velocity will also be remain same, that is 40 kilometer per hour. Okay. So why it is so? Because in a straight line we have a single direction. In a straight line we have a single direction, and in that case if the speed is, suppose this is speed. Okay, suppose this is speed. In that case, suppose this is speed 40 kilometer per hour, then its velocity will also remain same, that will be 40 kilometer per hour. So the magnitude of speed and velocity of a body is equal if the body moves in a single straight line. If a body is moving in a single straight line A to B, in that case the speed traveled by the body will remain equal to the velocity of the body, because the direction for the straight line is same for speed as well as for the velocity. I hope this point is clear to you, children. Now let us come to second point. If however it is given, if however a body does not move in a single straight line, then the speed and velocity of the body are not equal. Now suppose the body is not moving along a straight line. If the body is, so children, what I have told you, if a body is moving along a straight line, in that case speed and velocity both will remain the same, because both are moving along a particular direction. But suppose if the body is not moving in a straight line, it is moving in a haphazard manner. Okay, it is moving in a changing manner, like this. The body is not moving along a straight line, it is a straight line, and here is the curved line. The body is not moving along a straight line, then in that case the speed and velocity of the body will not remain equal. Why? Because at every point here the velocity will change, as well as at every point the speed will change. So speed and velocity both will change at each and every point when the line or the body traveling along the road is not a straight line, it is a haphazard manner or a zigzag way. Clear? Now let us come to the last point. The average speed of the moving body can never be zero, but the average velocity of the body can be zero. Now what does it mean? It means that the average speed of a moving body can never be zero, because average speed, what is the average speed formula, children? Average speed formula is total distance traveled upon total time taken. Okay, total distance traveled upon total time taken. So here we are taking actually the length of the path. Okay, we are actually taking the length of the path. So length of the path cannot be zero. Okay, so that is why the average speed of the body can never be zero, because here we are taking the actual length of the path. Okay, actual length of the path in total interval of the time. Here we are taking the sum of the actual length of the path, sum of the actual length of the path. So it cannot be 0. Okay. Now, but the average velocity of the body can be 0 because the average velocity formula is, children, average velocity is equals to total displacement upon total time taken. So total displacement means that, so children, here I was talking about, this is average speed. Okay, average velocity I'll tell you later on. Average speed is total displacement upon total time taken. I hope this is clear to you. Now if I talk about average velocity, so what is average velocity? Average velocity is change in displacement upon change in time. This delta x, delta denotes change. This delta denotes change. Okay, this delta denotes change. Change in displacement upon change in time interval. Now this can be explained, children, by an example which I am going to explain you right now. Suppose, let us say, just wait children. Let us say, so children, what I have told you, what is average velocity? Average velocity, average velocity is equals to change in displacement upon change in time interval. Okay, so what is change in displacement? Suppose a body moves from point A to, suppose the body moves from point A to B 5 meter and then return to the point from B to A again 5 meter. So what is change in displacement here? If I talk about change in displacement here, delta x, that is change in displacement. So children, delta x will be x2 minus x1. Now what is x2? What is x1? When the body goes from point A to B, so let us say this is x1, that is 5 meter. And when body returns from point B to A, let us say it is x2, again 5 meter. So what will be delta x? Delta x will be 5 minus 5. 5 minus 5 is equals to 0. Okay. So what will be the average velocity now? Average velocity is equals to 0 upon delta t is equals to 0. So that is why it is written here, children, that average velocity of a body can be 0, but average speed of the body can never be. Or children, or one more point I want to tell you, children, like delta x was x2 minus x1, similarly delta t will also be t2 minus t1. Let us say if the body moves from A to B and the time taken by the body was 1 second. Okay. And after returning from B to A, again the time is 1 second. Okay. So what will be t2 minus t1? T2 minus t1, T2 minus T1 will be 1 minus 1 is equals to 0. Okay. So here it will be 0 upon 0 is equals to 0. I hope children it is clear to you. All these points are clear to you. If you have any doubt, please comment me. Thank you.